Hello, everyone. I hope that you're having a good day. Of course, just kind of started for a couple of you guys. I'm going to do today just a little bit differently since I feel like we have plenty of time. And of course, you're watching the video. Yesterday, second period, got a little last minute on you guys. So I want to just make sure and continue to explain the synthetic division, which works us just directly into what we're going to do today. So yesterday I gave you guys number 7 through 12. Can't remember if I gave you guys number 15 and 16, but 15 and 16 I'm not going to sweat those today because they're exactly what we did or what we're doing today. So that will be explained in just a minute. So my focus is going to be these 6 questions. I'm going to go pretty fast through these so we can get to the notes. So again, yesterday we talked about synthetic division, the type of division that you guys can use whenever you have a binomial that's what we call linear and it has an understood coefficient there of 1. When that happens, I can definitely use this method, and it's really, really quite fast. So here we go. I'm going to take you through all 6 of these. Then you've got a note sheet that's probably either been handed out or it's headed your way right now. That is our notes for today. It's a really simple lesson. And like I told you guys, I will clarify any problems that we have on Friday. I'll be back. Okay, so here we go. Number 7. Remember, if x plus 5 is what your divisor is, we're going to set that equal to 0 and solve. And some of you guys are probably doing that in your head. You'll subtract 5. So negative 5 is the number that we put in our box. Then we take our numerator or our dividend, and it's in order. So we're going to put all of the coefficients from the very top one, x to the third, all the way down to our constant. So here's how I like to think through it to make sure we don't have any missing terms. I always say, well, what's my biggest one? It's definitely x cubed. What is x cubed's coefficient? 1. And then I work my way down. What's after x cubed? X squared. Do I have it? Well, sure, here it is. So that coefficient is 2. And then what's x? Negative 22. And then, of course, all the way down to my constant, negative 45. If I have any missing term, like we talked about yesterday, you have to include a 0 in its spot. I didn't have any missing terms. There's no zeros here. So then, of course, we start by bringing that first one down. And then we repeat the same 2 steps for the remainder of the time until we get to the end. And that is, we multiply the number in the box, negative 5, by the number under the line, positive 1. And then we combine. Okay, so what's negative 5 times 1? Negative 5. Then we combine 2 minus 5. So you do exactly what you see. You don't change signs using this method at all. 2 minus 5, negative 3. Then we multiply again. Negative 5 times negative 3 is positive 15. Then we combine again. Negative 22 plus 15, or I like to sometimes go backwards and do the positive number first. 15 minus 22, negative 7. Then we multiply again. Negative 5 times negative 7, positive 35. And then 35 minus 45 is negative 10. And there we have it. So I tried to explain this yesterday. So make sure you understand, since I'm dividing essentially my biggest term, x cubed, by my divisor that has the biggest term, x. X cubed divided by x is going to cause this very first term in my solution to be 1 less, x squared. And then it just works down. What's after x squared? X. What's after x? A constant. What's after a constant? The remainder. So our answer, the solution to this division, is 1x squared minus 3x minus 7, and then minus, and we always put our remainder on top of our original divisor, which is x plus 5. That's the solution of dividing. Okay, I hope that you understand that. The better you get at this, the faster you can go. Okay, look at this problem. I'm going to do it the same way. This time my divisor is x minus 1. I set it equal to 0 and solve. I add 1. So the number in the box is 1. Look at your dividend. Your biggest exponent is x cubed, and its coefficient is 1. And then I work my way down. What's below x cubed? X squared. Got it. -2. What's after x squared? X. Got it. Another -2. What's after x? Constant. Got it. It's 1. If there's any missing term all the way down to our constant, we have to include it. So we bring down that first term 1, and we start multiply, combining. Look, 1 times 1, 1. -2 plus 1, or 1 minus 2, -1. Again, 1 times -1, -1. -2 minus 1, -3. 1 times -3, -3. 1 minus 3, -2. Done. So again, I'm going to make this a little smaller just so I have a little space here. If I took x cubed and divided it by x, the result will be x squared, then x, then constant, then remainder. See, I've got them all. There's nothing missing. So my solution is x squared minus x minus 3 minus my remainder on top of my original divisor, which was x minus 1. Done. Okay, keep on cruising along here. We'll just keep knocking these things out. I'm going to take x minus 5, set it equal to 0, and solve. I'm going to add 5, so 5 is the number in the box. Look, x cubed is my biggest variable, so my coefficient for x cubed is 1. Work my way down. After x cubed, I've got x squared, -12. After x squared, I've got x, 33. After x, I've got a constant. I don't have a constant. Some people think, well, then I don't need it. Yes, you do. You're missing your constant. You've got to put a 0 there. I hope you understand that. Any missing term from your biggest exponent all the way down to your constant, you've got to have something in that spot because you're dividing. So here we go. We're going to bring down the 1 and multiply, combine. Multiply, combine. 5 times 1, 5. 5 minus 12, -7. 5 times -7, -35. 33 minus 35, -2. 5 times -2, -10. 0 minus 10, -10. So look, once again, I had x cubed divided by x, so naturally the result is x squared. Then after x squared, x, then a constant, then a remainder. See, everything is accounted for. If I had done something wrong, it wouldn't have been accounted for. It would have been a wrong answer. But here is my answer. X squared minus 7x minus 2 minus 10 over our remainder, or our divisor, x minus 5. Done. Okay, I hope that you see that. I'll leave that up there in case you're still trying to catch up. Next one, we take x plus 3, set it equal to 0, and solve. I subtract 3. -3 goes in the box. I start with my biggest exponent, that's x cubed. Its coefficient is 2. And then I work my way down. What's after x cubed? X squared, don't have it, 0. What's after x squared? X, got it, -14. Back on track. After x, constant, got it, 10. And I'm done. That's all of them. Bring down that first term, 2, and start multiply, combining. -3 times 2, -6. 0 minus 6, -6. -3 times -6, +18. 18 minus 14, +4. -3 times 4, -12. 10 minus 12, -2. So here we go. I have my biggest exponent, x cubed, divided by my divisor's biggest exponent, x. So naturally, the result is going to be x squared. Then we work our way down. X, constant, remainder. See, everything's accounted for. So my solution here is 2x squared minus 6x, positive, so +4, minus 2 over my divisor, x plus 3. Done. All right, 2 more that you were supposed to do for homework. And I know I'm giving you this homework. I'm not here today to check it, so I wanted to make sure it's all done correctly. So here 7 goes in the box. I know y'all see this work. You knew it. You don't have to do this if you know it. So my biggest exponent this time is x to the 4th, and its coefficient is 1. I'm working down from x to the fourth. X cubed, got it, negative 2. Then x squared, got it, negative 29. Then x, got it, negative 43. All the way down to my constant 8. Here we go. Bring down the 1. Start multiply, combining. 7 times 1, 7. 7 minus 2, 5. 7 times 5, 35. 35 minus 29, 6. 7 times 6, 42. 42 minus 43, negative 1. 7 times negative 1, negative 7. 8 minus 7, positive 1. So look, this time a little different than the last one because my biggest exponent was x to the fourth. I divided by x to the first. So naturally, my next one will be x cubed. Think about it, x to the fourth divided by x. And then it works its way down. Then we got x squared, then x, then constant, then remainder. See, everything's accounted for. That's how I know I did it right. So my answer is x cubed plus 5x squared plus 6x minus 1 plus 1 over your divisor, x minus 7. All right, and last one, again, if x minus 4 is my divisor, I set it equal to 0 and solve. X equals 4. It's in the box. I again start with x to the fourth, its biggest variable. It has a coefficient of 1, and then I work my way down. What's after x to the fourth? X to the third. I don't have it. 0. What's after x to the third? X to the second. Got it. Negative 7. What's after x to the second? X. Got it. Negative 32. What's after x? Constant. Got it. Negative 15. See, I included everything that I needed that I was missing. Bring down the 1 and start multiply, combining. 4 times 1, 4. 0 plus 4, 4. 4 times 4, 16. 16 minus 7, 9. 4 times 9, 36. 36 minus 32, 4. 4 times 4, 16. 16 minus 15, 1. Now look, my biggest exponent in my dividend was x to the fourth. I'm dividing that by my divisor, which is x. X to the fourth divided by x. I start with x cubed. Then we work our way down. X squared. X to the first. Constant, remainder. See? Everything's accounted for. So my solution is x cubed plus 4x squared plus 9x plus 4 plus 1 over the divisor, x minus 4. And that, you guys, is synthetic division. Now, second and third period, I'm not sure if I gave you guys number 15 and 16. It doesn't matter. We're going to do this today about whether or not it's a factor. I may have gotten a little bit ahead of myself to have you do those problems. So just kind of ignore them until today. It was pretty quickly explained. So we'll talk about it obviously more in this next lesson. So what I want you guys to do is now grab that note sheet that Miss Bowles has given you that says on the top, it says consider the polynomial function. See, what we're doing today is we're talking about, I guess what you would call this particular lesson is the remainder and the factor theorem. This is the remainder theorem, and then the factors on the back, which is kind of what I was talking to you guys about out at the bottom of the worksheet that you guys had yesterday, those last two problems that I said I got a little bit ahead of myself. So let me show you the point. Let me show you what today is about. It's using synthetic division. It's making a connection. So let me explain. We've talked about polynomial functions that are written in what we call function notation. Okay, f of x means function notation. And in the past, we have dealt with a problem like this where they give me a polynomial in function notation, just meaning f of x equals, and then some polynomial equation. And then it says, hey, find f of negative 1. So literally, what that means is you're going to go into this equation And every time you see x, see f of x, you're going to plug what into x? -1. You're literally going to go like this. Okay, f of -1 is going to equal -1 cubed. See how I just plugged it right here? Plus 9 times -1 squared. See how I just plugged it right here? Plus 22 times -1, plugged it in right here, minus 1. And you're literally just going to go to your calculator and you're going to type this in. You're going to put -1 in parentheses raised to the third power. Then you're going to write plus 9, open parentheses -1, close parentheses squared. That's important. Plus 22 times open parentheses -1, close parentheses, minus 1. And your calculator will evaluate this polynomial function and it'll say this. Hey, f of -1, basically this. When you treat x like it's -1, your solution is what? -15. That is what we've done in the past when they've asked us to, what we would call, this is called evaluating a polynomial function. You're basically just plugging -1 directly into the equation. All right, here's the point. I hope you can make this connection, because yesterday we talked about synthetic division, meaning dividing by x plus 1 when we're given some type of polynomial. So if I did that, remember how we did this yesterday and just a second ago? We set that equal to 0. What will it equal? Well, -1. -1 goes in the box. Now don't forget, what was the value we plugged in a minute ago? -1. Watch what happens when we take that polynomial and we divide using synthetic division by x plus 1. We start with our x cubed coefficient, 1. Then x squared, 9. Then x, 22. And then all the way down to our constant, -1. And we do synthetic division. Bring down that 1 and start multiply, combining. -1 times 1, -1. What's 9 minus 1? 8. What's -1 times 8? -8. 22 minus 8, 14. -1 times 14, -14. And watch this, guys. What is -1 minus 14? -15. Notice anything, guys? Notice that when we evaluated the polynomial function using the value -1, we plugged in -1 every time I saw x. We got the exact same result using synthetic division. There is a connection between evaluating a polynomial function and doing synthetic division. There's a connection. Okay, look, let me just prove it further. Look at number 2. If I went to my calculator and I plugged this in, I would plug in 2 times 4 raised to the 4th power minus 30 times 4 squared plus 2 times 4 minus 17. Here, I'll go do it. Watch, I want you to see it in case you type it in wrong. 2, open parentheses, 4, close parentheses, raised to the 4th power. I would just get in the habit of putting those values that we're plugging in into parentheses. It limits any mistake that you might make, especially when those values are negative. Trust me. Let's finish this off. And sure enough, when I evaluate this polynomial function for f of 4, I am given the value f of 4 equals 23. When I plug 4 into all the x's in this polynomial function, it gives me 23 as a result. Well, watch this, guys. If I were to take and divide by x minus 4, again, if I set that equal to 0 and solve, that's positive 4. Positive 4 is in the box, just like we plug positive 4 into the equation. You always start with your biggest exponent's coefficient. That's x to the 4th, coefficient 2. Then we work our way down. What was x cubed? Didn't have it, 0. What was x squared? Got it, -30. What was x? got it, 2. All the way down to our constant, negative 17. And watch this. I can do all this in my head. See, some of this math right here, if you try to raise 4 to the 4th power and then multiply it by 2, and then square 4 and multiply it by 30 and subtract, that math in your head gets difficult. But look at this math, all with my head. Bring the 2 down. What's 4 times 2? 8. What's 0 plus 8? 8. What's 4 times 8? I think y'all can do this, 32. What's 32 minus 30? 2. What's 4 times 2? 8. What's 2 plus 8? 10. What's 4 times 10? 40. And what is 40 minus 17? You better believe it, 23. Here's the point. Remainder theorem. If a polynomial function, f of x, is divided by x minus a, then the remainder is f of a. So if I use synthetic division, the remainder, what's left in the box at the very end, is the solution to f of a. Using synthetic division to evaluate a function is called, big tricky one here, it's called synthetic substitution. It's called synthetic substitution. So for example, for the rest of these problems, all they want me to do is to use synthetic substitution. But the difference is, look, they don't have it as x minus 5. They already have it evaluated for f of a. So that is the exact value that goes in the box. You don't change it because it's not written as a linear binomial. It's not written as x minus 5. It's saying, hey, use synthetic division for f of 5. So this is exactly what we're going to do. So let's start with our biggest exponent here, x cubed. What's the coefficient? 1. What's after x cubed? X squared. Got it. Negative 13. What's after x squared? X. Got it. 39. And what's after x? Constant. Got it. Negative 4. So we are going to use synthetic substitution, and remember, the remainder is the solution. That's what we're going for. So here we go. Bring down the 1, and here we go. 5 times 1, 5. 5 minus 13, negative 8. 5 times negative 8, negative 40. 39 minus 40, negative 1. 5 times negative 1, negative 5. Negative 4 minus 5 is negative 9. There is my solution. How would I write it? Here's how. F of 5 equals negative 9. Okay? You're welcome to plug it in if you want. You're welcome to go plug 5 cubed minus 13 times 5 squared plus 39 times 5 minus 4. But listen, this math right here, if you're ever alone without a calculator, this is way easier than typing it in, or not typing it in, plugging it in and using your brain. It's called synthetic substitution. So look at the next one. 10 goes in the box. We're doing f of a, f of 10. 10 is in the box. Here's my x cubed coefficient, 1. Work your way down. X squared coefficient, negative 10. Work your way down. What's my x coefficient? Not there, 0. All the way down past x to my constant, which I have negative 4. So there it is. Make sure you understand, if I'm missing a term, you got to put 0. Got to put it in its place. So here we go. Bring down the 1 and start multiply combining. Guys, what's 10 times 1? 10. What's 10 minus 10? 0. What's 10 times 0? 0. What's 0 plus 0? 0. What's 10 times 0 again? 0. What's negative 4 plus 0? Negative 4. My remainder is my solution. So f of 10 equals negative 4. That is my solution. That is using synthetic division, which we call synthetic substitution, to solve a polynomial function. The remainder is the solution. Say it one more time. The remainder is the solution. So let me show you this application here. It's got a little trick to it. It's easy, but it's got one little trick that a lot of times people forget. A bicycle manufacturer determines that the profit per bicycle when producing X bicycles per day is this formula. Use the remainder theorem, synthetic substitution, to find the profit by bicycle when 4 bicycles are produced each day. So 4, guys, goes in the box. 4 goes in the box. Now, here's the trick to this problem. Work your way down from x to the 4th. Your x to the 4th coefficient is negative 1. Then we work our way to x to the 3rd. Got it, 7. Then we work our way to x squared. Got it, negative 5. Then we work down to x, positive 1. And people think because that's the last term, we're done. But remember what I told you guys. You got to go all the way from your biggest exponent to the problem all the way down to your constant. Guys, I didn't go down to a constant. It stopped at x. Well, if it didn't go down to a constant, you got to have something in the constant spot. So again, if you're missing a term, you put 0 in that location. So that I've done. Now, let's go back. And let's work this thing all the way out. Bring down your negative 1. And here we go. 4 times negative 1, negative 4. 7 minus 4, 3. 4 times 3, 12. 12 minus 5, 7. 4 times 7, 28. 1 plus 28, 29. 4 times 29, might need to use a calculator for that. I've already done this, obviously. That's 116. 0 plus 116 is a remainder of 116. What's that mean? That means my profit is $116 when 4 bicycles are produced each day. Okay? And that, you guys, is synthetic substitution. It's very simple. It's using the same method that we talked about yesterday. So it's definitely something that you guys can do. Now let's flip over to the back. And this is what we didn't finish, and this is a walk in the park. So here it is, the factor theorem. We are checking to see if our binomial, see, look at all these questions. Is x minus 4 a factor of this? Is x plus 8 a factor of this? Is x minus 3 a factor of this? Is x plus 6 a factor of this? To be a factor, if a polynomial function is divided by a factor, then the remainder has to be 0. If the remainder is 0, it is a factor, meaning that if I graphed this line, it would go through that solution, through that 0, okay, like we've been talking about the last couple of days. So, for example, if x minus 4 is the factor we're checking, we're going to set it equal to 0 and solve. That's going to be a positive 4. Positive 4 is in the box. So here we go. We start with our biggest exponent, that's x squared. The coefficient is 1, and then we work our way on down. What's after x squared? X, I've got it, negative 16. What's after x? Constant, I've got it, it's 48. And now I'm going to multiply, combine. Multiply, combine. 4 times 1, 4. Negative 16 plus 4, or 4 minus 16, negative 12. 4 times negative 12, negative 48. 48 minus 48, sure enough, is 0. My remainder is 0. What's that mean? It means if I were to graph this polynomial function, I guarantee you it's going to go through or it's going to touch the x-axis right at 4. Okay? It's going to go through or it's going to touch the x-axis right at positive 4. So my answer here would be yes. It is a factor. Okay? And that's it. That's all there is to these. Look at number 7. We can go fast now. X plus 8 equals 0. Subtract 8. X equals negative 8. Put negative 8 in the box. X to the 3rd is my biggest exponent, so its coefficient is 1. X squared's next. Don't got it. Got to put a 0 there. After x squared is x, I got it, -1. Remember, the sign in front has to represent it. And after x is a constant, got it, 505. So here we go. Bring down the 1, and we start multiply, combining. Multiply, combine until we get to the end. What is -1? Or -8 times 1? -8. What's 0 minus 8? -8. What is -8 times -8? Positive 64. What's 64 times -1? Or I'm sorry, what am I saying? Combine those. What's 64 minus 1? 63. What is -8 times 63? I don't know that one. -8 times 63 is -504. Let's go back to our paper. What is 505 minus 504? 1. Guys, it's really close, but is it a 0? Definitely not. Then my answer is no, it's not a factor. If I were to graph x cubed minus x plus 505, it would not cross or touch the x-axis at -8. I have a feeling it would be pretty close, but it will not cross or touch right on -8. Okay, let's do 2 more, and then this lesson will be yours. If I take x minus 3 and set it equal to 0 and solve, the number that goes in the box is positive 3. 2x to the third is my biggest term, so 2. What's after x to the third? X squared, got it, -4. What's after x squared? X, got it, 46. What's after x? Constant, got it, -156. So here we go. Bring down the 2. Start multiply combining. 3 times 2 is 6. 6 minus 4, 2. 3 times 2, 6. 46 plus 6, 52. 3 times 52. 3 times 52 is 156. Guys, what's 156 minus 156? 0. Yes, this one is a factor. If I graph this 2x cubed minus 4x squared plus 46x minus 156, I guarantee it would cross or touch my x-axis at positive 3. Last one. -6 goes in the box. See, x plus 6 was the factor that we're checking. We start with x cubed. What is x cubed's coefficient? 1. And then we work our way down. Don't let this one trick you. What's after x cubed? X squared. I don't have it. 0. What's after x squared? X. I don't have it. 0. What's after x? Constant. Got it. 216. So see, this one's going to have 2 zeros, believe it or not. So now we're going to bring the 1 down, and here we go. What's -6 times 1? -6. What's 0 minus 6? -6. What's -6 times -6? 36. What's 0 plus 36? 36. What's -6 times 36? -6 times 36 is -216. So sure enough, 216 minus 216 is 0. Yes, this one also is a factor. If I graphed x cubed plus 216, I guarantee you it crosses through the x-axis at -6. I promise. Go try it. You're welcome to. So there you have it, guys. Pretty simple. So let me tell you your homework. I want you to, on the homework assignment that is either already at you or it's coming your way, I want you to do all 8 problems, 1 through 8. I want you to do 1 through 8. That's your assignment, due tomorrow. If you have questions tomorrow, I'll answer them. I'll check the work, not only on this worksheet, but also on the one that was due today. So there you have it. That's the factor and remainder theorem. Use synthetic division. Easy peasy, lemon squeezy. All right. Hope you have a great day. I'll see you tomorrow.